Okay, I'm going to look at a problem from Chapter 10 homework, specifically problem 34, the very last one. This was a custom created question. So at the top you'll see it says instructor created question. Well, you can in the MML, just can't see it here. But it's a good conceptual question because a lot of students just don't know what to do when they read a problem. So we've got a psychologist. He obtains a random sample of 20 mothers in the first trimester of their pregnancy. The mother asks to play Mozart in the house at least 30 minutes each day until they gave birth. After 5 years, the child is administered an IQ test. It is known that IQs are normally distributed with a mean of 100. Good. If the IQs of the 20 children in the study result in a mean of 104.3 and a standard deviation of 14, is there evidence that the children have higher IQs? Use the alpha equals 0.1 level of significance. Okay, so let's see what we got here. This problem involves which of the following? Is this a proportion or a mean we're looking at? Well, if it's a proportion, it would give a percent or a decimal amount, but I don't see that. I see, oh, look at that, mean of 100. That seems to be B. All right, now we have a quantity of 104.3. Which of the following variables? Okay, where the heck is it? Okay. 20 children in the study result in a mean of 104.3. So it's a mean value, but is it population mean or sample mean? Oh yeah, that's a sample mean, so we're going to take A. All right, then we've got part C. The quantity 100 is which of the following variables? Well, again, oh, there we again have the word mean of 100. Oh, wait a minute, that's the mean of IQs, which are normally distributed. So that's the population mean. Oh, there, I'm looking at my screen more than looking at you. I hope you don't mind. All right, so let's see what else we got here. Uh-oh, we got more questions. Quantity 14 is which of the following variables? 14, standard deviation. Okay, once again, that's either population, sigma, or sample S. Well, wait a minute. It says children in the study had a mean 104.3. We said that was X bar. So 14 is S. Boom. All right. Quantity 20. Uh-oh. Oh, it's right here. Random sample of 20. Oh, there's an easy one, right? We all know that. That's N. All right, and which calculator function would you use to compute the p-value? Well, unfortunately, this was developed by a person that used to run this class, and she only used the calculator. As a matter of fact, the calculator videos that are included in this class were done by that same person, and DeFranco. So it's a case of, fortunately, the names, while cryptic, are pretty descriptive. Z-test, well, that would be testing a single parameter and knowing the population standard deviation. T-test, we don't know the population standard deviation. One prop Z-test, well, that would be a proportion test. So that would be testing the proportion. And then T-interval, that's a confidence interval. That's chapter 9. So I'm going to say it's t-test, which, by the way, is the correct answer. So let's see here. Boom. Oh boy, nice work. Aren't you happy that your instructor actually knows how to answer these questions? Okay, something I mentioned real early on, and it's not part of this question, but can we run a t-test when we only have a sample size of 20? We're always told you have to have 30 or more, but we have to have 30 or more if the population is not normally distributed, and we are told IQs are normally distributed. So yeah, this is legitimate. And one of the nice things I like is after I do these things, and normally you're not asked all these questions, but if I go to my handy dandy calculator and pick up t-test that says I have to know the null hypothesis mean, mu sub 0, and we've got that right there. So it's 100. And then it asks for x bar. And we know x bar is 104.3. So that's actually greater than the 100. So we're doing a right tail test to see if they have higher IQs. So okay, that makes sense. This is a right tail test. We also have to know SX, the calculator calls it SX. That's just saying it's the standard deviation of the sampling variable X. So, okay, that would be 14. Then we have to know N, and we know that N is 20. So, hey, we've got everything, because then it asks, is it right tail, left tail, or two tail, the not equals. Well, like I said, it's a right tail, so I'd be ready to calculate and generate my values. So that's pretty slick. Got any questions? Let me know, but that's me doing a video. I hope you like it. What?